Hello, welcome to the channel. Today we are going to check what layer normalization is. And this is the very first thing about normalization. And we are going to learn other normalization techniques in the coming videos. Right now, let's stick to this layer normalization. Before that, let's learn what normalization really is. Basically, normalization is just we take a set of values. We'll find the mean, variance, standard deviation, and apply some formulas on it. And after that, we'll adjust values in this matrix array, whatever it is, so that it won't be an absolute value like 0 or 1. And basically, we just want the model to be unstoppable during training. If it stops at one place, then the model stop learning. And if you have seen my previous videos, I explained about two algorithms like he and Gaming algorithms. They are used for basic initialization. That means when I take the weights at the very first step, I'll apply this as a process of cleaning. But normalization is the step we do before activation in during training, so that we won't stop the values from stopping stopping the training. And that's why we are using normalization. And before normalization, I have to tell you about this z score. This is what layer and batch normalization are based on. Z score is basically a statistic concept. It is used for values that are greater than 30, and formulas are also pretty similar. If you want to dig deep, I'll attach a link what this Z score is. There is other thing called T score, but it is not relevant right now. And let's dive into the formula for layer normalization. Here we'll need the mean. You guys know what mean is. And next up, we need the variance. Variance is basically the square of the difference of each value to the mean. That means something like x minus mean whole square. And if we add root to this, then it will be standard deviation. And standard deviation is basically quite important. And let's check out the formula and write some code, because I'm going to show how it works in PyTorch too. That's quite simple. Before that, let's use some NumPy to really understand what's happening under the hood. For that, let me take the mean first. That will be np.mean of the x. X is just the input vector. I mean input matrix, feature matrix, whatever we call it. And next up, we'll take epsilon. Epsilon is basically 0 point followed by 5 zeros and a 1. And we use this to avoid the zero division errors, because the formula has a division parameter, this one. For that, we use epsilon. And here mu is nothing but the mean. Let's find the variance too. Let's call this var, and numpy just calls it var2. Np.var for x. And let's find the initial normalization normal value for this. That is x minus mean divided by the square root of variance. That means this, it is already squared, so we don't need to take a look. And we'll add eps, that means epsilon, to arrive at a stable value. And after in this we have two parameters, gamma and beta. One is scale and other is shift. How many, I mean, scale is basically the stretch or the tightness that we apply to the set of values, that means plus or minus. And shift is basically just we add extra values to maintain the overall weights standard, because z score always returns something like 0 and 1 for mean and variance. And we use these to balance stuff, and in some we'll just skip beta. In further normalization we learn what why we skip beta. So to arrive at the last output, I have to take the x normalization value and multiply it with gamma and add some beta. Let's return the output rounded up to 5 decimals. Let's run this. This should be 5. Let and this is working. Let's submit this and done. This layer normalization is basically used in CNNs, LLMs too, but LLMs shifted to some other stuff. CNN is basically convolutional neural network, and there is batch too. And let me show you how this stuff works in PyTorch, because PyTorch made things easy. Let me import torch, and let me take the torch.neural network. Let's call it NN, and let's say take some samples, and that will be torch.rand n. I'm going to give a range. I need two matrices. One is for 3, that means 3 rows and 4 columns. Now I'm going to apply I'm going to take the layer normalization here. That will be nn dot layer norm. I'll take it as 4. 4 is the shape I'm taking, or this is called affine transformation in what we call geometry. This is used to preserve the straightness, preserve the straightness of a straight line, ratios, parallel value, parallel lines in a shape, even though the shape is totally changed. And this is value is used for that. And let me apply the normalization for this layer of samples. And if I print the output dot shape, we will arrive at the same shape, 2 3 4. And if I print the output, it will look something like this. And here are the changed values. Let's check this with the samples. You can see the values changed a little, 1.0078, 0.6378. This is layer normalization, and this is used in the forward passes mostly. And in the next video I'm going to discuss about batch normalization, and after that RMS. And I will also cover the ones that aren't covered here, like spontaneous. There are other normalization techniques too. As far as you know, there are total of 6, and we'll initially learn each of them. Right now this is about layer normalization, and this is quite important for this GPT architecture. And it is used twice. We need to understand normalization from the basics to understand what attention is. And attention is what drives all the LLMs currently that are there. The context window, everything is just based on attention. So please go through this. Thank you for watching. Please like, share, and subscribe.